I see it.
Cool, 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 cool. Um, Actually, do you want to start with the eigentrust thing first?
Yeah, sure.
All right. Why don't you start?
So I think as you said, it was a very, very busy sprint. There was a ton of stuff that we were doing. I think my favorite accomplishment was actually the easiest thing that I did. Sorry, am I sharing the right thing? No. Um, ah, okay, let's try that again. There we go. Yeah, so the easiest thing I did was the coolest thing that I did, and whenever that happens, it's reason to celebrate. So I guess as a little bit of background, Eigentrust is this algorithm which kind of works like PageRank. It allows you to run it over a graph, and there's a Wikipedia article about it, so it's not something that is like a proprietary algorithm. It's a way of doing reputation management over a peer-to-peer network, according to Wikipedia. In any case, there's a team called Karma 3 Labs, which have created an implementation of this, which allows us to really easily run the Eigentrust model across anything in our event table. And I'll show you why that is cool. But basically, what I've done here is created a very, very simple starter notebook, which would allow anybody to connect to the open source observer database and data warehouse, and then run Eigentrust on anything they want. And we'll be doing a data challenge about this in a later this week, hopefully. So basically, if the one thing that's a little bit annoying sometimes is that you have to pip install to get in, and there's some weird like dependency stuff. So I think I noticed this as well in my local environment. There's some kind of mismatches, but in any case, I've got this installed now. It will run, and basically right now it's completely open, so you can just authenticate. I'm authenticating into the open source observer data warehouse as well. And now a lot of the fun stuff is going to be playing with this query. And I've done like the most basic, boring possible query that you could imagine. But Eigentrust, it basically takes three variables. I is basically the entity that you want to create a reputation score for. J is basically the edges, the things that they have in common. So it could be a project, it could be a transaction, like another user that they interact with. It could be a GitHub repo that they star, which is the example in this case. But there's all sorts of ways that you could define the thing that they are interacting with. And then the amount here, the v value, is basically some kind of weighting that you want to give it. In this case, this is really, really big, really, really basic. All I'm doing is basically looking at developers who are interacting with a repo, and by giving it a star. And so that's the query that I'm going to run right here. So this is just hitting the playground data set, so it should only take a minute. If I were doing this against all of the event data, this query would take much longer to run, maybe a minute or so. But then what I have now is a data frame, and then this is actually more code than is required to run this. But you can basically call Eigentrust, it's running it, and it is working out these values. So this was actually quick, less than 1 second. And you can see here, these are the values that come back. Now, again, I'm just using a playground data set. I'm not doing anything particularly interesting. I'm just looking at stars, and I haven't gone in and joined the artifact IDs on the GitHub users. So this is like a very, very, very basic 2-minute implementation of it. But effectively, each one of these 859 rows, that represents some kind of user. And the V value represents their kind of rank in this graph. And so you can see here that there are a few people, a few users that are very, very influential, and then a long tail of ones that are less influential. And so this is like one of the many ways that you can actually identify who are the most impactful contributors, or what are the most popular projects, or what are the repos that are trending right now. What are the on-chain contracts that are most important in an ecosystem? All of those are questions that you can answer very, very easily just by playing around with some of the variables that you set in this query. And then, running OpenRank against that. And yeah.
So in this thing, how do you set the seed nodes? Sorry, maybe I missed where you did that.
In this case, I just seeded it simply off of all of the nodes that are interacting with it. So I didn't go in and do anything fancy there.
Well, no, I mean that's just to select the whole graph. But
Right.
I thought the way that the Eigentrust model works is that you have to actually pick which nodes to start at. Right.
In the most basic implementation, no, you don't. It's kind of running global Eigentrust effectively.
Okay.
Yeah, but
I'm
we'll
sure
need to
there
make
is
one
a way
which
to do
shows
that.
an example
Yeah.
of seeding it differently, and then playing with the v values and kind of weighting those somehow.
Hmm. Yeah, makes sense. Cool.
Yeah.
And yeah, like you said, I think once you join this back, I guess it would be a second. It'd probably be more efficient to do it as a second query once we join it back to like the artifact table and populate what everything is. This will look pretty magic.
Yeah, exactly. I mean, I can look it up right now, but I don't do SQL live on demos.
Yeah, smart. Cool. Awesome.
All right, I'll hand it back to you now.
Awesome. Thanks for joining, Matt. Feel free to chime in if you have any questions at any point.
Yeah, I think Matt might have just been on the token engineering call that we had. So
Oh,
good to
nice.
see you here. Yeah.
Yeah, feel free to chime in with questions. Otherwise, we'll blaze on ahead.
No questions. I'm just going to be the dumbest person in the room for a while, but it's the first step in due time. So happy to be here and thank you very much.
It's a small room.
So I wanted to start with like this, which we finally shipped. I know this was something we want to do for a while. It's basically just like the automated documentation generation from dbt generate, straight from our our repo. In theory, this should always be like a one-to-one mapping of what we currently have in the main branch. It is fully continuously deployed from GitHub Actions, which you can take a look here if there's ever an issue. It's probably in this in this workflow here, deploy dbt docs. What's nice about this is that like it both gives full documentation over all of our raw source data, which are all public data sets, as well as like our entire data model. So I'll start with the data model.
Yeah, can I give you one to look at? Because this is the one I wanted to show as well. So go to, or is that okay? Or did you have one that you wanted to do?
I guess if you have a specific one.
Well, yeah, maybe start with like artifacts, but there's also one that's been labeled a bit, so that would be nice to see. Like the, if you go to metrics, yeah, pick one of the code metrics, for instance.
Cool. Awesome. The other thing that's nice is that like they actually fully specify all of our metadata, which will be useful when we get to indices later on. So you have all the metadata up here. We have a good sense of how many rows and how big this model is. That's super useful for us in terms of like understanding costs. Yeah. Okay. Cool. So these descriptions you've populated, which is great.
Yeah, click on one of them, it'll expand and you can see it. So do, I don't know.
I think one of the things that will be really awesome is to the extent we start getting more of the community involved, we could probably get help annotating some of these things because we're probably missing quite a few. So that probably corresponds to something in here.
Yeah, exactly.
Yeah. Cool. Yeah, so it's just the YAML file, right? And you're just populating descriptions so far.
It's just the YAML file.
Yep. And that all pops up here. I think to me the coolest part is this bottom part here, where if you go to code and you go to compiled, this is like fully copy pastable, right? So I can copy this to clipboard. I can head over to BigQuery. I can launch, in Studio. Maybe I'll limit 5 for now. And let's hope this runs.
That'll run. That's not the coolest thing, though. I will show you the coolest thing.
What do you think is the coolest thing?
Well, let's see the result that we get back. Um, That should be fast, but yeah. Well, while it's going, I'll show you the coolest thing. Oh wait, did you do a? Why is it writing?
Should be a select.
Oh, okay, sorry. Yeah, that's fine. Go to. Yeah, go back over here and hit it's like the director graph icon on the bottom.
Oh,
Yes.
the lineage. Yeah, the lineage is cool too. I'm hoping in the future we will start using Dagster for stuff like this. But yeah, this part is cool too. So we can kind of zoom in and see all the models that it depends on, and then you should be able to click through and see like the lines that connect these, and all of these are defined by like an individual SQL file somewhere in this mark directory. But yeah, this part is also cool. There's a lot of cool things about this.
I mean, what I like about it is you can kind of see where we have some spaghetti code, right?
Oh yeah, tons of spaghetti code.
Well, I don't think it's that bad. I think it's really just around the int events area. That's where things are.
Well, it's mostly the complexity around here, right? Post events, it's like pretty straightforward. But yeah,
so that was one of the things I refactored last week. So that part is now cleaner, or at least more consistent.
Yeah, makes sense. I think we should consider, what we want to do with this int events table in the future. But this is pretty good for now. Hopefully the BigQuery thing finally finished. Yeah, cool. It does run. Yeah, and I might as well go over the indices thing since I have this open already. This might be relatively new to you, Carl. But we now have this new index metadata. So if you specify an index metadata, specify a name for the index, which I usually prefix with IDX, and then an array of which columns you want to put, because you can have multi-column indices. It'll build these indices like on copy, and this should happen nightly. You can verify that that's working properly here. So if you log into the actual Postgres database, you'll see that for our MART models, for artifacts, for example, we have two indices. That's artifact ID and by name. And the reason why we have these is because previously, like, our API is fully served by this Postgres server, right? And before we hit indices, this was like hella slow. It would take on the order of like 2 minutes to pull up something from artifacts because it had to do like a full sequential scan. And now if you run this, it should, it's pretty fast. Less than a second. So this is selecting by name, namespace, and source. But hopefully these things should be faster now. There is some weird bug where this doesn't always work, and I don't know why. Here's a good example of one where it doesn't always work. There should be 3 indices here, so that you can fetch artifacts by project ID or fetch artifacts by artifact ID, and then another one by, I think, project source namespace name. There's a weird bug that I need to find what's going on here, but some of the indices might be missing sometimes, but hopefully not too many of them. But then if you go into here, it also pops up in the metadata, and then you can also query it directly in BigQuery as well. That hopefully once we fix that bug, or some of the indices are missing, hopefully the API will be super snappy.
Do you want to jump to the new OSO project page?
Sure. You're talking about project pages?
Yeah.
Yes. Do you have any questions about like how to manage indices, I guess? It seems pretty straightforward.
It seems straightforward, yeah. I feel like once I get into it, I'll probably hit some things, but looks clear for now.
Okay. Yeah, this was mostly just fixing, what was broken before. So you can also hopefully you noticed that it was pretty snappy as well. But this is entirely powered by our new code metrics DBT model. So it'll load the project metadata and all the metrics on server side on requests and cached, and then all of this is pre-populated, so we don't no longer have to like wait. There used to be spinny dials on every single one of these, which is kind of annoying. But yeah, this is back up and running. We'll want to add more stuff in the future, but at the very least, we unbroke what we previously broke.
Yeah, pull up Uniswap or one of the big projects as well. I made a few fixes yesterday that I haven't showed you.
Oh, nice. What did you add?
Fixes. So,
Log in.
yeah, there's a bug here. It's going to break, I think. Oh yeah, there. Okay.
Oh, what happened?
I don't know. You're still logged in, but it just doesn't resolve.
Okay.
Anyway,
Do you know what caused this?
I don't. But if you go back to the project, you'll be logged in.
Oh, okay. All right. Well, we should file that bug.
Okay.
Cool.
Yeah,
So what'd you add?
Well, I got the gas fees and stuff working again. So there were some changes in the calculations, and now these are good. Like we had some math that was previously hard coded, and I've taken that out because now we calculate it upstream. But
Okay, cool.
What we're missing now is getting all the other networks that we support, because maybe this is my lead-in. We now support six superchain networks. I guess we have Arbitrum and effectively ETH mainnet as well. But now what this is doing is just pulling the Optimism stuff. But in theory, we could be adding everything up or just filtering on any of the networks that we support.
Yeah, that's a good segue to our source data. So we have a ton of source data now. All of these are public data sets that we are currently hosting in some way or another on BigQuery. So for all of them, you should have blocks.
That's a small one.
Yeah, blocks, traces, transactions. Sometimes we have a little bit more like logs and stuff like that. But this is super exciting. I think. And similarly, all of this SQL is copy pastable, which is really cool. So it's all hosted on Open Source Observer. If it's superchain data, which is the main thing that we're focusing on right now, it should be under the superchain data set. But all of this is copy pastable. We don't have a ton of like really good documentation on this yet, which I think that's something we should probably aim for in the next sprint or two, is like, actual documentation that explains that this exists now and is like a pretty cool public good. We might even want to put some branding around it, but people should have access to a lot of free public data sets now that are kept live and up to date thanks to our partners at GoldSky. So yeah, we should totally on that. I think this is going to be pretty cool.
All right, let me take a screen. I have a nice thing to piggyback on off of this. Okay, so another big change that we made last week was a update to OSS directory. So previously you had to enumerate each of the networks that you were on. Oh, sorry, can you see my screen? Yes, okay. You had to enumerate each of the networks that you were on. So if you were on, Optimism and Base and Metal and Mode, you'd have to list each of those individually. Now there's a new tag that you can use, which basically says, I have a deployer or I have some kind of address and it is on any EVM tag. It is on any EVM chain. It might not be on all of them yet, but what that will tell the indexer is to kind of go look, and wherever you see that address deploying something or interacting with something, then that should be attributed back to the project. And so this was a pretty big unlock, because historically we'd only spent a lot of time labeling addresses for Optimism. We hadn't touched these other chains. And of course, there's a lot of projects that are on Optimism but are also on these other chains. So now basically we have just massively increased the amount of projects contracts that we have coverage for. Same projects, but now all of the chains that they're building on. and have updated the docs, and some people have been submitting pull requests now that conform to the new tag. So that's really cool. The other thing I can share is what this actually looks like now that we have actually 7 networks. We do support PGN as long as it lasts. But if I look at a project that is on all 7 chains, I can basically see its on-chain metrics across those 7 chains. So here is safe. You can see how long it's been on each one. You can see how many contracts it's deployed on each chain. Get the transaction count, gas fees, etc. And yeah, as of yesterday, we have metal as well, so that data is flowing. I think this is so cool. There's so much you can do with this.
Yeah, this is awesome. Yeah. Did you want to walk through at all any of the like model refactors? Is there anything there that's like kind of hairy that?
Nothing too hairy. Probably the main thing to note here, at least going forward, is that if you take like code metrics, for instance, right? These all depend on. Sorry, let me go to the one upstream of that. So this pulls from int code metrics. If I look up int code metrics, then this is a pretty. It looks like a complicated model, but it's actually just going in and unioning all of these, modular metrics. So previously we just had like massive set of CTEs that would get kind of aggregated. And what I did is kind of break everything down into these atomic metrics that can be calculated independently. And so whenever you create a new metric, effectively, well, yeah, let me show that. So you would go in, or I'll pick a code one. Let's just take bus factor, for instance. Let's look at the compiled code. So here's the formula for calculating it. This is one of the more involved ones. It has some rankings and so on. Here's like a simpler one for contributors. So you can kind of look at each of these things atomically. The format is that there's this kind of a prefix, and then you have 2 underscores, and then it gives you the name of the metric. And then if you come in here, you can see how all of these metrics are unioned together through this like one big statement over here. Now, each of these metrics has been defined so that you're going to be able to pull it at a variety of different time intervals. So we currently have, I think, 7 days, 30 days, 90 days, 6 months, 1 year, the life of the project, etc. Obviously, Ray, there's like a open discussion item about what we want to do here. But for the time being, you can specify different time intervals. And for any metric, you can decide which one you want to bring into the our kind of master table of code metrics. So here, for instance, we have a lot that are calculated at the 6-month level. This one, contributor count, there's a version which is since the project began. There's a version which is 6 months. If you look at the on-chain metrics, these ones are a bit more, a bit different. You can see same format here. We're just kind of unioning them all and then doing these aggregations. These ones are 90 days. These ones are 6 months, etc. So you have different options here. And then effectively you have one final select statement, which kind of brings them all in and joins it on the data that we want about the project. So that was like a lot of the refactoring I was doing. And the nice thing is that there are a lot of models that previously were kind of being used, but a bit hard to follow, that have now been gotten rid of. Yeah, I don't know if we've actually discussed that previously, Ray. Does that bring up any questions for you?
No, I mean, we might refactor this in the future, but that's kind of the beauty of intermediate models, is that it doesn't really matter as long as it all gets out to the marks the same way. So, yeah, I think it's fine for now, and we'll figure it out when we figure it out. The other thing, this is a super random tidbit, is I had a conversation with Alan Ransel and trying to nerd snipe him on the idea of I think the thing that's really cool about the way that DBT works is that like every single thing in that lineage graph, right? Every single node in that lineage graph, in theory, it is a separate view in your underlying database. In this case,
Right.
BigQuery. And so there's nothing that prevents us from, simultaneously running this pipeline on some other kind of backend. And I think he's like really excited about the idea that every single one of these nodes could actually, every single run of every single one of these nodes could be a separate CID of a, file on IPFS that like runs, on Bakoya or some other kind of decentralized query engine. So there's something that's actually like uh, the way that we've structured this means that it could be more easily decentralized than we had in the
Cool.
past. Like you would basically build a decentralized connector for DBT that is powered by, some other backend, which could be some combination of Parquet and, you know, um, some kind of decentralized query processor. So, um, I don't know. We might have community help there for free, which might be kind of exciting.
Yeah, it definitely seems like one to nerd snipe some people on.
Yeah, exactly.
Well, speaking of maybe Filecoin and Protocol Labs, should I share the retro funding results there? Did we have anything else?
Yeah. I'm curious. Like,
Okay.
well, yeah.
We
I don't know
covered
if
everything,
Matt, you
right?
have any other questions.
Yeah, we covered everything.
Um, I am kind of curious what you think most interesting results out of that are.
Oh, one other thing, actually, I didn't have this in the agenda, but I'm going to break my rule of never doing live SQL. But this is an easy one. Oops, I already messed up. Okay, we have these. Okay, so what this is basically doing is there's a way of kind of determining if a project meets the retro funding, Optimism retro funding requirements for being open sourcey enough. So this is like a bit of a landmine. But let me, share an example. I'll share us, so it's a bit easier. Project name equals open source observer. And so basically, I was doing this with Reuven the other week. Pretty straightforward, but we were basically getting the project in. Oh, sorry, there's some weird duplication here. I need to fix this. But it basically pulls every repo that belongs to the project, confirms that's not a fork. We ignore forks, and then it kind of looks at a few things. So number one, there's a way of kind of mapping the different licenses that we see and determining whether it's like a permissive or a restrictive license or something that requires manual review. There's also a check that sees what language it's in. And Optimism right now is only interested on repos that have at least some component which is in Solidity or TypeScript and JavaScript. Interesting preference. And then there's like a way of filtering how much activity it has. So again, I'm mainly showing this as a kind of an example of how you can configure some filters to see which repos might qualify or might be interesting. As we think about doing some spam detection on submissions to open source OSS directory, there's perhaps some inspiration we can get from this. But yeah,
Is the language thing exhaustive? Like, if I'm in a monorepo that has both Solidity and TypeScript, will it integrate both?
nope, that's a shortcoming. We're just pulling directly from the GitHub API, which returns the dominant language.
Oh, because the GitHub UX does show a distribution, right?
Yeah, I know. You have to get that separately, unfortunately.
Yeah, like I'm thinking the Hypercerts repo, for example, is a combination of the Solidity, but also the web app.
Yeah, in general, I think a lot of them will have. Well, let's see what Hypercerts says actually. Oh. So okay, no, it gets approved.
Yeah, but it only shows Solidity, which is fine. I don't know how it determines that Solidity is more important than TypeScript in that one repo, but anyway, good to know.
Yep.
Cool.
Yeah. So just last thing, do you want me to show the Filecoin blog post?
Yeah, sure.
I think that's here. So basically, Filecoin, they did a fork of RetroPGF, their own kind of round. It was their first round. There's a nice spreadsheet here which shows all the results, all the projects, and how much they received. And there's a link to the applications. There's a really good article that Kieran put out, kind of discussing the results and how people voted and so on. Did some of our own analysis. As always, you can view it and you can run it directly right over here. As we've come to do, there's some nice data visualization in it. I think like the main takeaways that I'll call attention to. So number one, the spread was very, very flat. If you look at the optimism distribution, which was also viewed as being flatter than people expected, the Phil RetroPGF one was very, very flat. And again, kind of what that means is that the difference between the best project and an average project was only 2x, right? In the case of Optimism, I think it was like 5x or something, maybe higher, 6x or 10x actually for the very best one. And another thing which is interesting is that there wasn't really a very strong difference between the type of project. So you could have like tooling, or you could have a community one, and in general they tended to get the same amount. So a thing that I definitely harp on whenever I look at these things is, okay, what signal are you sending to people about what you value and what you want to build more of? And I think when you have a flat distribution and it's even unclear across the domains that you support, which ones are going to get more funding, it's a pretty muted signal. So that's one of the, I think, shortcomings of the round. Another thing, this is more just about like the formula itself. Optimism had the same issue, but you basically have votes that the badge holders will give. And the way that the scoring is done is it takes the median. And so you have a project here. Where's the example? Yeah, this one here. So one of the top 10 projects actually did not get many votes, but it had one person who voted 16 for it, who gave it the highest possible score. And so because it cleared quorum and it didn't have a lot of votes, it actually did very well, as compared to a project like, it did better than Lotus, for instance, which is a very, very popular project that probably everybody voted for. So that's kind of a issue with the voting mechanism itself. The thing that I guess we were most interested in is kind of looking at if you were to get metrics and apply data to improve the rounds, where could you turn? And very similar to what Optimism had, you had projects that were open source projects, and they would submit links to GitHub and other places where you could see their work. And then you had a long tail of everything else. So it could be Twitter influencers, it could be people making media on YouTube, it could be like contributing to the Filecoin Slack, etc. So like a very long tail of contributions that are, I don't want to say that they're not impactful. It's just very, very difficult without context to understand what that impact was and how to compare a tweet thread with something on PhilScan. Very difficult. And so you can see that, again, apart from GitHub, there was very little consistency in the types of things that projects were using. In our case, we only look at the open source and the GitHub contributions. In general, projects that had some kind of GitHub link, regardless of what category they were in, tended to perform better. Again, it wasn't like a huge difference. It was only, say, 30% higher in terms of funding. But like the last area where there was some funkiness is actually just looking at what they were claiming. So were they claiming a part of a repo? Were they, an entire org space? Or was it multiple repos scattered across different org spaces? There was a lot of overlap across the claims that people were making. And this is probably best illustrated by this exhibit here, which shows the GitHub org over here. So you have some GitHub orgs like the Filecoin project, and you had 15, 20 teams that were all claiming some impact on that org space. In other cases, you had projects that were like here's an example that had two different projects all claiming impact on the exact same repo. And so very, very difficult for anyone who isn't like intimately familiar with the differences between the storage part of the organization and the network part of the organization would have no way of kind of identifying which contribution was more impactful. And because the distribution was flat, this was actually a pretty effective strategy. So I think Titan ended up being one of the projects that got, relatively speaking, much more funding. The other thing that we can do is kind of look at the input that was required. So a very crude metric, but looking at the number of developer months by project. So effectively, how many contributors over what period of time have been working on this GitHub org or this GitHub repo. Obviously, there's some very big projects here like libpdp, IPFS, Filecoin project, ChainSafe. They've been around for a long time. A lot of people working on them, and so on. And so they're pretty big over here. Then you have some others which are like either a smaller team or they haven't been around as long. Again, nothing wrong with that, but just the funding was fairly consistent among projects, despite the fact that the amount of time or man hours or man months that had gone into it was very, very different. Again, man months is a bad metric, but at least as a way of looking at how much work has gone into this project, it's kind of a useful way of sizing things, making those comparisons. And then last, you can do the same thing at like the GitHub repo level, and you can see that again, there are some projects that were claiming lots of different contributions, a lot of overlap. It's very difficult to understand, for all these things that were contributing to Lotus, which ones had the most impact. You had an application from FEM, you had one from Team TSE, you had one from Boost, one from Spade Client, etc. Very, very difficult to parse their respective contributions unless you really, really know that repo very well. And so the last thing that I'll share here is that if you actually look at the amount of fill that a team got based on the size of the team, so literally like, if you were to look at the ROI of how much time you put in return for how much fill you got out of it, there was a very, very strong bias towards very small projects that were kind of a standalone. So with, less effort, let's say, you could do something for 3 months and get maybe 2,000 fill, and that would be much higher ROI than working on something for 3 years with 10 people and getting 4,000 fill. Now, obviously, this is just an experiment. It wasn't designed that way, but if this were to scale, you definitely need to make sure that there isn't a bias or kind of a tendency to get teams to make their work appear as discrete as possible so that they might get a bit more funding. Sorry, there was actually a fair amount of stuff here. I'm curious, Ray, how much of that resonates.
Yeah.
And, what
yeah, it's a good initial investigation. I think one of the things I'm kind of curious about, because one of the things that Lauren had mentioned was well, maybe you have different objectives, right? Like maybe it's flat on purpose. So maybe the purpose here is that there's only limited funding, and the purpose of this is more about having the amount, being able to dedicate more of the money towards long tail projects to kind of draw them into the ecosystem, as opposed to really rewarding the top projects, right? Or there might be other objectives in the future. So if you imagine a distribution where the y-axis is some metric for impact and the x-axis is some sorted set of projects, right? There's different ways that we can kind of crop that graph to meet different objectives, and I'm really curious to apply that in the future, where imagine something like what we're doing for retrofunding 4, but in addition to that, you can you can give it a haircut, right? So then the max amount that any project gets is some amount, and really you're optimizing for the long tail. Or instead of a haircut, you do a longitudinal trim where you get rid of the entire long tail and you're just allocating all the money towards high impact projects. And there's all sorts of different ways we can slice and dice that, and I'm curious. Yeah, that'd be a cool way to kind of engage with both the objectives that they might have for any particular round, but still using metrics in a smart way. So
Yeah.
that's what came to mind.
I mean, I think definitely it's interesting that like Glyph is one of the ones that came to the top because it's an external project, right? Small team, so actually a very, very good fit for this type of funding, right? Um, but like I think to your point, if you were to filter a bit better and say, okay, we really want to target projects that maybe haven't had 3 years of support from Protocol Labs network or from Protocol Labs directly, right? Then I think you could probably run it the same way that you did, but the funding would be more meaningful, and it would definitely give the projects at least would be much more discreet.
Yeah. Yeah, this is cool. I think the other thing that comes to mind from a product perspective is I'm curious, like, how many of the analyses that you did on this overlapped with the same type of analysis that you did for Arbitrum and Optimism, or were they like totally different things that you looked at?
Yeah, so this was, I will say, the very easy thing to do was this thing at the end. So like the part that looks the hardest was actually the easiest. The part that took the most time was the stuff in the middle, not this, but sorry, it was the stuff around looking at their links and just kind of making sense of what was there, because that data wasn't already normalized and in a consistent format.
Well,
Yeah.
I mean, like,
Which
the
is
types
good.
of things that you looked at in this blog post, are they the same types of things that you looked at for Arbitrum, for example, or were they kind of different types of insights?
I would say this has the most similarities with some of the retro PGF stuff. So there's that graph and this one.
Yeah. I'm wondering, like, because all of these will embody in a collection in the future, right?
Yep.
And we'll have funding data, in the future that's normalized. So how many of these things, do we want to embody? Like, you remember the collections, the comparison table for collections, where you can kind of select any two collections and see different things from it. I think it's still up.
Let's
I don't know
see.
if
I want to see if it works.
it might not, because I don't think we updated it to the newest. Yeah, I don't think we upgraded it to the V1 API, so it's probably
Okay.
depending on endpoints that no longer exist. But I'm wondering, like,
We should do
yeah, as
that.
we start to think about product experiments, like, how many of these things, like, this is purely in table form, but of course, like, in the future, you might want to have different types of graphs that show comparison graphs between two collections as well. Like,
Right.
how many of these things have you found resonated the most that you might want to be able to do for any two collections, or things like that would be a good thing to kind of start enumerating in issues now.
Yeah. I mean, I think the thing that has consistently been very, very useful for people is like some kind of a table, right? So
Sure.
just the basics. Here's the project and what it's been doing. Where this gets pretty custom are things like capturing, voting data and funding amounts and so on. So we can obviously just bring that data in, and then we can run stuff on top of it. But until we kind of
I mean, presumably that's what the stuff that we're collecting into OSS funding or the funding data sets. That's gonna
exactly.
right.
Yeah.
So yeah, I think it'd be cool to see what kind of interactive visualizations we might want to do in the future, and what kind of knobs we want people to be able to fiddle with. Because one of the things that you do is you kind of look at different, like, the funding amounts and the distribution of the funding amounts and compare them across programs.
Yes.
I can see a world where that's really fascinating, right?
Yeah.
Like,
Yes.
totally. And you can pick any two, like, rounds basically, in any, and see how different it is.
Yes, exactly.
So yeah, I think we should, let's noodle on it, but it'd be cool to file some of these into issues and we can try to prototype some of them.
Definitely.
Cool. Any other questions from the audience? I had one more thing I was just going to demo to you. I feel like it's going to be most useful to you, Carl, but like it may not. I don't know, maybe not because it's all in TypeScript. Worth a shot.
Let's do it.
Okay, so
Is this the GitHub validator?
no, this is OSS directory transformation frameworks.
Oh, right. Okay. Yeah.
Have you played with this yet? Like,
I looked over your shoulder when you were doing it last week.
oh, okay. Well, all right. I'll spend less than 30 seconds on this then. It's basically you can form a bunch of transformations, and this is assuming that you're not. Basically, it's anything that's not going to change the schema. Should be a transformation, because if you change the schema, then you got to increment the API. Sorry, the version number. If you increment the API, the version number, then you're going to start breaking stuff downstream. Upstream. So there's some documentation here on how to create these one-off transformations, and it's basically like things like I want to remove all contract addresses. I know we're not doing that anymore, but like things that don't change the schema basically is there's some instructions on that. So I have two examples. One is this like EOA to any EVM, right? That's like a good example of a transformation.
Yeah.
So you can take the existing, if there's no blockchain data, just return. Otherwise, if it includes EOA, remove anything that's not any EVM, right? So you can write these like really simple transformations that get run on every single project file or every single collection file. This is probably less than 20 lines of code or so. And then the way you run it is by I'll show you one more example that I found really useful. It's not even a transformation. I just needed this because I needed to figure out which validators were breaking. So this doesn't even change anything. You'll see that like literally I'm just always returning back existing. The only thing I do is I'm counting how many addresses are affiliated with each network in global state, and then I can print that out, and that's just like for me to count, like to be able to easily scan every project file and count like what addresses belong to what network. So I'll show you how what that looks like. So you can abuse this for whatever purposes you have, but this is kind of what it looks like.
Yeah.
It's ugly, but it gets the job done. So that like this is basically how I was looking for. This is how I figured out which networks we had to have validators for, right? Because we have a lot of networks, we don't have validators for most of them. But in reality, we only need validators for 4.
Can you give me
we only have 11.
just a dump of that actually? I need something.
Yeah,
I wanted to
exactly. I figured this might actually be useful to you. So
Yeah.
it's all in TypeScript, so it may not be useful to you, but feel free to use it if it.
Okay, cool.
You can figure it out.
No, I don't know if you noticed, but I did write a few validators of my own in TypeScript, or utility functions rather.
Cool.
Great. My lunch just arrived, so I need to jump out, but this was a really fun demo. And Matt, let's definitely connect. I'm so glad that you joined. This is obviously focused on a lot of the things that we're shipping internally, but I would love to hear more about what brought you here and what you're interested in. So feel free to share something async, and we can connect.
Sounds good. Appreciate it.
All right, it's a wrap.
All right, thanks.